So good afternoon to all. Thanks, Chairperson, for introducing me. Audible, my tone is audible.
Yeah.
Yeah, it is my pleasure being here, part of this conference, and I'll talk today energy transition with hydrogen for sustainable mobility. In our laboratory, IIT Delhi, we have done almost 4 decades on hydrogen, mostly combustion engines, use of hydrogen in combustion engines, and also we started fuel cell as well. And today, chairperson asked me why energy transition, why need hydrogen? We are talking now battery electric vehicle. Why need hydrogen? Suddenly we are talking hydrogen. And hydrogen IC engine over hydrogen fuel cell, which will be potential technology. So I will try to give some highlight of this all. So before going there, I'll take some few seconds. This third innovation cycle, internal combustion engine, was invented 1900. But before 18th century, I think the 18th century, Nicholas Otto, he invented spark ignition engine, Otto cycle. Rudolf Diesel, later diesel engine. In the same period, Sir William Robert Grove, he also invented fuel cell. Fuel cell is not a new technology, it is already available, but internal combustion engine carries for more than 1 century because crude oil revolution. But at this moment, the depreciation of crude oil depletions, and we are importing around 87% of crude oil. As per Sustainable Development Goal, SDG 7 UN's, it will be affordable, reliable, sustainable. So, today I came from my place to here, I traveled by car, so emitted 1.5 kg of CO2 for 12 kilometer. And I in future, the same thing I'll write, it should be zero with hydrogen, green hydrogen or biofuels. If you go again, biohydrogen with carbon capture, then I can remove the 1.5 kg of CO2 from atmosphere. That is towards net zero. And energy independence, our Prime Minister declared 2022 in Independence Day. This is for urban Nirbhar Bharat, 100% energy security by our own resources. So we are going towards 100% energy security with our own resources. Net zero emission as per United Nations, as much as possible cut the emission from the energy system. But actually, whatever we are able to do the atmosphere should be lower than whatever removed from the atmosphere. Then we can balance the CO2 emission net zero. We are having lot of energy sources, but we need lot of sink to be built. One is the forest and other biomass going on, but we have to build, then only we'll achieve the net zero emission. Whatever adding the CO2 should be lower than whatever removal from the CO2 from atmosphere. So, 87% of crude oil is imported from other countries, only indigenous 13%. Then what is the energy security problems? Another one is affordability is not there, it's increasing price. So, and equity case also, burden of our people. The prices are increasing, disadvantaged people, societies will not able to use of this crude and based oil. And of course, we are having coal surplus. So coal cannot be eliminated, but coal-based fuel with the carbon capture. That could be one of the solution. Our automotive industry went 1991, the mass emission norms implemented. Then it goes again reverse norms, BS1, BS2, BS3, BS4, and jump to BS6. Now we'll go for BS7 or beyond that what. Now we are in the position of zero emission targets. The similar way, FAME, the policy 2015, then battery electric vehicle, then next stage of battery electric vehicle will be hydrogen fuel cell electric vehicle. This is one route. Another route is conventional. Beyond BS6 will be hydrogen internal combustion engine. This is another transformation. So these all SDG 7 goal. It should be affordable, reliable, sustainable, modern. So fossil fuel suffering, energy security point of view, other than coal, environment and energy economics, energy equity. But the green hydrogen, all meeting energy security, environment, everything. We will maximize green hydrogen with our renewable energy sources. 2030, 50% energy comes from renewable, and surplus renewable electricity, then possible renewable hydrogen. Then comes battery electric vehicle and hydrogen vehicle. Why? Battery electric vehicle only is for lower range in the city, urban, but longer range then either hydrogen internal combustion engines or fuel cell electric vehicle. Battery, 50% cost is for battery, and affordability another one. So these are the alternate technology will come for higher ranges. These are the complete value chain, renewable, and the electrolyzer, converting hydrogen and storing the tubular, then in the vehicle with the type 3, type 4 cylinder, 350 bars, 100 bar. And we have the option, one is the battery electric for smaller range, and remaining will be hydrogen IC engine or fuel cell. So which one that? So first we'll see internal combustion engine. We have seen these are three major challenges: backfire, high NOx emission, power drop. Everybody having the doubt about the NOx emission will be high. But that is for hydrocarbon fuel is the challenges more because of smoke versus NOx, particulate versus NOx. Simultaneous control is the challenges, but here only one pollutant, NOx. That can be tackled with the technology. And one more is backfire, because hydrogen having quick reactions and leads to backfire, but means without entering into the cylinder with the residual gas, get the ignition combustion. Another one is the power drop. This is surprising for anybody. Hydrogen having high mass, energy density, 120 megajoule per kg. But in case of volumetric, very, very suffering around 9 megajoule per meter cube, because energy density high, but the problem will be volumetric. Three major challenges addressed for our laboratory. We are there. Backfire eliminated with combined technologies of direct injection or timed manifold, injection timings, and EGR, exhaust gas recirculation, or water injection, lean burn. We have done water injection extensively. It worked well. NOx emission will be less than 0. But this technology will be backfire also can be eliminated, combined together, and power drop, supercharging, or turbocharging. So combined together of all technology, we can efficiently use hydrogen in hydrogen IC engine. That emission will be almost 0, less than 18 ppm NOx. And you are getting power, torque, and the fuel efficiency also 5% higher compared to normal. So for 30%, it will come 3 to 5%, 33, 35%. This one technology we are having in India. Another one, fuel cell, everybody is talking on, right? The fuel cell, the electric vehicle next stage, this having 3-4 components majorly. One is a battery, fuel, and another one is electric motor and controllers. But without battery, put the fuel cell, then fuel cell power the motor. And fuel cell need hydrogen storing in the cylinder. It's the anode, cathode, and membrane, simple electrochemistry, hydrogen passing anode, and electron, proton separated. Electron goes anode to cathode, but proton goes from anode to cathode through membrane, then reduction happening in the cathode side. This simple chemistry, electrochemistry, but this has one challenges. Positive point is there higher efficiency. Is there 50% efficiency you can get it. Internal combustion the vehicle point of view 25%, engine point of view 35%. So double you can get it, and But you can go the fuel cell, stack power increases, your efficiency drop. This is one of the dilemma on the fuel cell. If you want to get high power density, lower efficiency. It's the reverse. If lower power, then high efficiency, because this is the characteristic of the fuel cell. And these are the norms. Power density, again weight per liter has to go. Another one is cost, is very high, 4 times higher in large scale. These are the commercially available, of course pilot scale. Then all are there. One is the battery is very, very less, you can see, no need otherwise. Fuel efficiency very high, and cost is a drawback. And these all IC engine versus fuel cell, all, well, one of the issues there, the fuel quality. In case of fuel cell need 99.999%, and IC engine does not have, that is that. But the levelized cost we have done, the fuel cell versus IC engine, levelized cost of transportation comprises 3: capital cost, operating cost, and maintenance cost combined together. So let us say 1x IC engine 10 lakhs, and 1.5 lakhs 15 lakhs, another one is 2x 20 lakhs. So 10 lakhs is IC engine, 1.5x and 2x of fuel cell. We got interesting that, see, if you get 1.5 times, always the levelized cost of transportation will be lower from beginning to even 1.5 lakhs kilometer. But if you go 2x, that be 20 lakhs, beginning is a higher, after some time it's a takeover and coming down. What is indicating that fuel cell vehicle cost should be 1.5x time lower than IC engine. That is mean today 40 lakhs, IC engine 10 lakhs, the segment you can take. Fuel cell cost should be 15 lakhs, then only levelized cost of transport will be getting lower. That will be advantage to the user. So these are the high cost. Why fuel cell high cost needs high fuel quality, air quality, and durability. Cost reduction because the all material like graphene, graphite, titanium, and catalyst platinum, these are expensive. The catalyst platinum is very expensive material, and other bipolar plate, also graphite you can manage, and current collector copper ever. So many materials using, we have to reduce it, we have to go alternative material that is cheaper. If that is reducing, then cost will come down. Even our policy also going, or scale up of this all material also come down. And air quality is another one, like Delhi, lot of air quality problems, how the cathode side will work well. Not IC engine can work any environment. But here, cathode need purity of the air. Otherwise, the catalyst will react if it's sulfur or some other CO will be present in the atmosphere. Durability, of course, this is the solving now. So if this is sorted out, and fuel cell cost will come down. Yeah, this is finally what we have seen. 2 3-wheeler all will be electric 100%, and then fuel cell and ethanol biofuel vehicle will come the middle range, and trucks everything then go hydrogen IC engine, because of that is a 200 kilowatt 300 kilowatt. That is what we see. And now critical 2037, today is a gasoline, CNG, diesel. 2037 we introduce 10% ethanol, hopefully 2025 20%, and 2037 we should have 1/3 of renewable energy. Then 2037 we have the 2/3, 66%, and 2047 then we'll go for 100%. Finally it's coming in longer run, then renewable hydrogen and electric vehicles and biofuels will maximize this all. Then we'll achieve, if not possible achieve 100%, we can go nuclear route, then electricity to hydrogen also can be possible, the pink hydrogen. And then again lot of scope there, coal to hydrogen with carbon capture. In this way we can get 100% energy security than our own indigenous. So this is the one thought process we can achieve 2047, moving toward that. Thank you so much for your passionate listening that.